Hello everyone, you are welcome back to Dual Study World. Today our lesson will be on circle theorems. Yes, circle theorems. Now, before we begin, we have some terms that you have to define. You have circumference, you have diameter, you have radius, chord and arc. You have to define all these terms. Now let's begin. Let's say we have a circle with center O. Let's say we have a circle with center O. Here the center O. Yes. So for the first one, we are saying that circumference. So what is the circumference of a circle? Circumference of a circle is the distance around the circle. So the distance around the circle becomes the circle circumference, or the circumference of the circle. So this distance around the circle is called the circumference of a circle. And the center is the midpoint of the circle. Now, diameter. What is a diameter? A diameter is a straight line drawn from one end or one point of the circumference, which passes through the center to the end of the circumference. So the key word is that passes through the center. You have to bring it, or it won't define the diameter. So diameter is a straight line drawn from one end of the circumference, which passes through the center of the circle to the other end of the circumference of the circle. Okay, now radius. So what is a radius? A radius is also a straight line drawn from the center of the circle to the other end, or to one end of the circumference. So we have, let's say our circle is here, we have the center to be O. We are saying that the radius is a straight line drawn from one end, or drawn from the center. So here the key word is that from the center. So drawn from the center to any point on the circumference. To any point. So this becomes our radius. So this is the diameter. So you have diameter. We have our diameter, we have our radius. We have our radius. So radius is a straight line drawn from the center. So here we have from the center to any point or any point on the circumference. And the diameter, you have a straight line drawn from one end of the circumference, passing through the center to the different end, or to another end of the circumference. Now, let's say we also have a chord. So, what is a chord? We are saying that a chord is a line, or a straight line, that divides the circle into two segments. Yes. So, as for a chord does not pass through the center of the circle. So, this is a diameter, but a chord is also a straight line. You see, the diameter divides the circle into two equal parts, but a chord does not divide the circle into two equal parts. Rather, it divides the circle into two segments. So this is a chord. This is a chord. This chord divides the circle into two segments, the bigger segment and the smaller segment. They are saying that this smaller segment is called the minor segment. The minor segment. And this bigger segment is called the major segment. So we have the major segment and the minor segment. So we are saying that the chord divides the circle into two segments, which are the major segment and the minor segment. Yes. Now let's continue. We have an arc. So we are saying that an arc is the distance. So so we have the chord, we have the arc. The arc is let's label this. We have P, we have Q, then we have R, we have S here. So the distance from P, Q to R becomes the arc. So this is the arc. So the arc is the distance, or the arc is part of the circumference. So this whole this whole distance is the circumference of the circle, yes. And this smaller portion of the circumference becomes the arc. So the arc, we have the major arc and the minor arc. So this becomes the major arc and this becomes the minor arc. Whilst this becomes the major segment of the chord and this becomes the minor and this becomes the major segment. Now let's continue. We have defined all these terms. Now let's continue. Let's move on to the properties of circle theorems. The properties of a circle. Now we are saying that the first one, or the first property is that, so our first property is that the angle a chord or an arc subtends at the circumference in the same segment of a circle are equal. Now, before we even get to the properties, we have to define a certain word, and that word runs through all the properties. We have subtend. The word is subtend. You have to define this word. So this subtend is, so let's take a circle. We have the chord here. So if we say that, so let's say you have P, Q. Let's say you also have it R. So let's say the chord PQ subtends an angle X at the point Q. So how will we write that? So the chord PQ or the arc PQ, so the chord or the arc PQ subtends an angle X at the point P. So what we mean is that from one end of the chord, you draw a line to R, and then you also bring it back to the other end of the chord. So this becomes the line PQ subtends an angle X to the other point R. So the chord PQ subtends an angle X at the point R. So this is the meaning of the word subtend. Now let's move on to our first property. So we are saying that the angle a chord or an arc subtend at the circumference in the same segment of a circle are equal. So let's say we have this circle with the center O. We have the chord, we should have the arc. We are saying that the angles that is subtended to the circumference of the circle. So in the same segment, so we have the major segment and the minor segment. So in the same segment, the angle, so this chord subtends an angle to the circumference of the circle. This same chord subtends an angle to the circumference of the circle. This same chord subtends an angle to the circumference of the circle. We are saying that if all these angles are in the same segment, and we can see that they are all in the major segment, so they are all in the same segment. So therefore, all these angles are equal. So if this angle is theta, this one too is theta, this one too is theta. So the angles are equal because they are subtended by the same chord, and also they are also in the same segment. If it were to be on the minor segment, then it would be like this. So this chord subtends an angle to the circumference to here, the same chord to the circumference. So this one too, they are the same, they are from the same chord, and also they are in the same segment. So if here is angle theta, here too is angle theta. So they must be in the same segment and also from the same chord, then they will become equal angles. Now, our next property, we are saying that the angle a chord or an arc subtend at the center of the circle is twice the angle it subtends at the circumference of the circle. So let's say we have our circle with a center O. So we have our circle with a center O. We are saying that the angle that a chord or an arc subtends at the center of the circle. So we have the chord or the arc. And you are saying that the angle that this chord subtends at the center of the circle, so here is it, is twice the angle that it subtends at the circumference of the circle. So we are saying that the angle that it subtends at the center is twice that it subtends at the circumference. So if the circumference is theta, then the center will become 2 theta, because the angle that it subtends at the center of the circle is twice the angle that it subtends at the circumference of the circle. Now let's continue. Number 3. The sum of the angles a chord or an arc subtends at the circumference of the opposite segment of a circle is equal to 180 degrees. So we are saying that, let's say we have a chord or an arc. So a circle with a chord. We divide the circle into 2 segments. So we are saying that the sum of the angle that the chord subtends to the opposite sides or to the opposite segments add up to 180 degrees. So let's say this chord, the chord PQ or the arc PQ, subtends an angle to the circumference of the circle. This same chord, so let's call the angle theta. This same chord PQ subtends an angle to the circumference of the circle in the opposite segment. So the first theta, the first angle theta, is in the major segment, the major. And this theta, or this angle, let's call it alpha. This angle alpha is in the minor segment. We are saying that since they are from the same chord and they are acting in different segments or in opposite segments, their sum gives us 180. So theta, angle theta plus angle alpha gives us 180 degrees. So this is the third property. Now the fourth property, I say that the angle, the diameter of a circle subtends at the circumference of the circle is 90 degrees. The angle that is the diameter of a circle subtends at the circumference of the circle is 90 degrees. So let's say we have our circle with the center O. We have our circle with the center O. We are saying that the diameter, so a diameter is a line drawn from one point of the circumference which passes through the center to the other end of the circumference. So we are saying that the diameter or the diameter subtends an angle to the circumference, and the angle is 90 degrees. So it means that the diameter subtends an angle of 90 degrees to the circumference of the circle. It may be, since the diameter divides the circle into 2 equal parts, then it means that the major and the minor are the same. So here we don't have a major segment and a minor segment. They are equal segments. So the same angle will be in the opposite segments, the same 90 degrees. So from the third property, we learn that if we add the angles at the opposite segment, it should give us 180 degrees. So we have 90 plus 90 giving us 180 degrees. So this confirms the third property. Now the fifth one, we have equal chords or arcs subtend the same angles at the circumference of the circle. So equal chord or arc subtend the same angle at the circumference of a circle. Let's say we have a circle with this chord, and then you also have this chord. So you have this chord which subtends an angle to the circumference of the circle. And this chord, let's call this chord called AB, and call this chord called PQ. So this chord AB subtends an angle to the circumference of the circle, and this chord PQ also subtends an angle to the circumference of the circle. Let's call this angle theta and this angle alpha. We are saying that if the chord AB is equal to the chord PQ, if the chord AB is equal to the chord PQ, so if these chords are equal, if AB is equal to PQ, then the angle theta is also equal to the angle alpha. Then theta is equal to alpha. If the chord AB is equal to PQ, then theta is equal to alpha because they are equal chords and they all subtend angle to the circumference of the circle. So if the chords are equal, then their angles are also equal. Now let's continue. The sixth property, we have equal chords for arcs subtend the same angles at the center of the circle. So equal angles equal arcs or chords subtend the same angles at the center of the circle. So let's say you have a circle with center O, and you have this chord called AB and this chord. So you have chord AB, and also we have chord PQ. We are saying that this chord AB subtends an angle to the center of the circle. Chord AB subtends an angle to the center of the circle. So let's call the angle theta. And chord PQ also subtends an angle to the center of the circle. Let's call the angle alpha. We are saying that if the chord AB is equal to the chord PQ, then theta is also equal to alpha. So we are saying that if chord AB is equal to chord PQ, then theta is equal to alpha. If chord AB is equal to PQ, then theta is equal to alpha. So this is the sixth property. Now the seventh property. The angle between a chord and a tangent at the end of the chord is equal to the angle in the alternate segment. The angle between a chord and a tangent at the end of the chord is equal to the angle in the alternate segment. So let's say we have a circle. Let's say you have a circle with a chord, and you also have a diameter. So this chord subtends an angle to the circumference of the circle. When you have a diameter here, at the end of the chord, here is it. So you are saying that, so this chord called PQ subtends an angle to the circumference of the circle at the point A. So at the point A, and you have a tangent to the circle at the point Q, or at the end of the chord. We are saying that the angle between the chord and the tangent, let's call this angle theta. The angle between the chord and the tangent is equal to the angle in the alternate segment. So the angle here, theta, is equal to the angle here, also called theta. Now, let's continue. And then final property, we have the opposite angles of a cyclic quadrilateral are supplementary, or they add up to 180 degrees. So we have a cyclic quadrilateral. So we have a circle with a cyclic quadrilateral. So this is a cyclic quadrilateral. We are saying that this figure, the opposite angles add up to 180 degrees. So let's say you have A, you have B, you have C, you have D. We are saying that A plus D is equal to 180 degrees. And then C plus B is also equal to 180 degrees. Now this brings us to the end of this lesson. Now we know the properties of the circles. Now our next video will be on how to use these 8 major properties to solve questions. So stay tuned and please watch, subscribe, and then share my videos. This is Dual Study World. Bye bye.